The first step in converting text data into numerical data, which can be processed by our mathematical machine learning models, is to create a mapping between the tokens of the text, typically the words, and an integer. And we call this mapping between token and index a vocab or vocabulary. Really, the index which each word is mapped to is arbitrary. It doesn't tell you anything about which words are similar or any rich representation of that word. But typically, the next steps involve learning or downloading richer vector representations of each word known as embeddings. And those vector representations of each word are kind of like an arrow in space, and you can imagine similar words have similar arrows that point to them in space, so they'll be clustered together. And stacking those vector representations for every word in the corpus gives a matrix, and we call that the embedding matrix. So this is where the vocab is useful. It's useful because it allows you to map the word to an index, and then you can index that row of the embedding matrix to get the word embedding for this particular word. So we're gonna go through a series of steps to get the final representation of the word that we want. We start off with a body of text. We tokenize that text to get the individual tokens. We use a vocabulary to map from the tokens to an index, and then we use that index generated from the vocabulary to index an embedding matrix to get out a vector representation of the word. There's a lot going on there, and we'll get into more details of that, but the main thing that I want to focus on here is the vocab, which is just a map between token and index. Very simple. So you can create a vocab from an iterator using torchtext build vocab from iterator method. So you can import that from torchtext.vocab, import build vocab from iterator. The method takes in an iterable, which gives a list of tokens as you go through it. So let's implement that here. So I want to build a vocab, and I'm going to use the build vocab from iterator. And here I need to pass in an iterator. It says an iterator to build vocab. It must yield a list or an iterator of tokens. So what does that mean? Well, basically it needs something which I can iterate through, and turn by turn is going to give me a list of tokens. What this build vocab from iterator is going to do under the hood is it's going to go through all those different examples of tokens, come up with or generate a set of all of the unique tokens with none repeating, and then it's going to map them to an index. So this vocab is going to be a dictionary-like thing where I can give it a word, it tells me the index. So let's do that here. The typical way to do that is that you define a generator. So let's call it token. Let's actually call it yield tokens. And what this thing is going to do is it's going to go through this list of sentences, which I could have generated from a data set. And then it's going to get the tokens for each of them. Well, to get the tokens, I use the tokenizer. I call the tokenizer on the example. That'll give me all the tokens in each of those examples, one by one. And then I'm going to yield those tokens. So this thing is going to be a generator when I call it. So if I call yield tokens, it'll give me a token generator like that. And then this thing I can iterate through. Each time I go through it, it's going to yield me some tokens, and I can pass that token generator into the build vocab from iterator. We'll run this in a sec and break it down and kind of see exactly what's happening in there, but this should be it if I've implemented it correctly. So let's just run that and see if it works, and everything seems to have worked. So now we've got that vocab to kind of check that things are working, we can use some of its methods like get string to index. There's going to be a dictionary which maps from string to index in the data set. So I'll run that and see what comes out. And you can see this is one of the key things which is included within the vocab now. It maps between string to an index in the data set of all the words. So let's kind of break that down a little bit more because we covered quite a lot there. So again, the tokenizer, it takes in body of text. In this case, it's a sentence with many different tokens which need to be broken up, and then it returns those tokens. So let's print the tokens here. So if I run that, you'll see when it runs, here are the tokens for the first sentence, and here are the tokens for the second one. So that's what the tokenizer is doing. And as I go through this, as I created this generator, I'm going to go through it one by one, and that's happening inside the build vocab from Iterator. So under the hood, in this implementation of this method, it's going through this generator, it's iterating through it. So under the hood, it's saying, for token in token generator, and every time it does that, it runs this to yield some tokens. And then eventually this vocab has a mapping between string and index and string as well. So just a few things. Here I've got a iterable list of sentences which I could have generated from the dataset, but in practice you'd probably load these in on the fly in the generator itself, essentially, rather than having all of them in a variable in advance, as many text datasets are going to be far too big to fit in memory. And when you call this method, like I said, what it's doing is it's basically going to iterate through all the examples of the text and build a set of unique tokens and assign an integer to each to produce a mapping between the token and that index. And so this vocab that we've generated has dictionary-like functionality. So I could do something like vocab, and I could index a particular word in that. So I could say the, and if I run that, then I'm going to get out a 0. So that's showing me that the index for the word the is 0. So it also has a bunch of other useful functionality, including a lookup ability to go the other way around. So I could do vocab dot, lookup indices, for example, lookup indices or lookup token. So I could pass in a integer, it's going to give me the string of the token there, or I could pass in this one takes in, as I can see, a list of strings, and it's going to give me a list of the integers. And what else does it have in here that's worth looking at? It also has a state dictionary, which I can load in, or I can get out. So this vocab can actually allow you to save the mapping just like parameters of any other torch layer. It also has methods to, for example, move everything to GPU or CPU, and much more stuff which I won't go into. So I just want to highlight one mistake here which might confuse people, and that would be passing in the example instead of the tokens. So if I didn't create this token generator and I just iterated through the examples, then I don't need it, and I didn't have any of that stuff by mistake, then I'd run this and I would get something very wrong. Let me just delete this stuff. So if I were to run that, now you can see this is not what I was after. And what's happened there is it's gone through each of the sentences and it's iterated through each of them, and it's taken each character as its own token. So So that's not quite what I wanted. So to recap, a vocab is just a mapping between each token and an index. And the vocab is going to be useful because we will use the word index to index the row of an embedding matrix to get the representation of the word as a vector.